Hi, my name is Christopher Chen, and this is my Physics 2212 lab, Charged Tapes. The goals of this lab are to create a charged tape, figure out how that charged tape interacts with other charged and non-charged objects, find the excess charge on that piece of tape, and then model those interactions between pieces of tape using ClosScript. The findings are that the tape was charged positive. The tape has a charge of 6.6 times 10 to the negative 9 coulombs, and there are 4.12 times 10 to the 10 electrons lost by the tape. There are three key concepts. The first one is Newton's second law, gives us that F net is equal to ma. The second key concept is Coulomb's law, which states that an electrical force between two charged objects is directly proportional to the product of the quantity of their charges and inversely proportional to the square of the distance between them. This comes out to an equation where F, the force from the charge, is equal to K Q1 Q2 divided by R squared times R hat, where R hat is a directional unit vector, and K is 1 over 4 pi epsilon naught, where epsilon naught is the permittivity of vacuum space. The third key concept is gravitational force near the surface of Earth. This is simply just F is equal to negative mg, where g is equal to 9.8 meters per second squared. Key assumptions of this lab are that A, the tape will act similarly to a point charge, and therefore the tapes will be simulated by a point charge in the center of the tape. 2, that air resistance can be ignored and has no impact on the system. And 3, both tapes have the same amount of charge, and that the creation process for both of the tapes will create tapes that have identical amounts of excess charge. To create the tapes, we put down a base tape and then ripped off a top layer of tape to create a U-tape. And then that's how we charge the tapes. And we bring them and record whether or not they attracted or repelled to different objects. And then eventually we used one piece of charged tape to place beneath another piece of charged tape that would then lift that other piece of charged tape using electric force. The important part from here is that it is the interaction between the charged tapes and the pen, where the pen was rubbed onto a cloth to become negative, which is a known reaction, and then this pen was then held near a charged tape, and they moved toward each other, therefore the tape had to be positive. The system is the floating U-tapes, and the surroundings are the held U-tape and the Earth. Here is some experimental data and calculations, where the first three are all data that was measured, and then the last two are calculations. Here, Newton's second law is applied, where the force from gravity was equal to the force from the charges because of Newton's second law and the fact that the tape was not moving because it had zero acceleration. And also, we can also see the assumption that Q1 is equal to Q2, which is because that we assume that the processes for creating both tapes were made tapes that were exactly the same. On the left, at the top, are my initial conditions, and then beneath my calculations, and then beneath that is my function called E field, and then below that is where I define my objects, such as the spheres, which are the tapes, and then the arrows, which are the forces. And on the right are my results in my computational model. Due to the tape being positively charged, as shown by the pen and the tape experiment, there is an electron deficiency. For the U-tape to float, the net force on the tape has to be 0, and therefore the force from gravity has to be equal to the force from both from the held U-tape onto the floating U-tape. And then some sources of error are bad measurements with the tape's length, the width, and the distance between the tapes, and some rounding errors due to calculations. If the electrons had positive charge and the protons had negative charge, then the E fields would flip directions, and instead of pointing away from the tapes, they would point toward the tapes, and the U tapes would be negatively charged instead of positively charged. But the phenomenon of the floating tape would still be there. The reason you had to touch the tapes as little as possible is because electrons transfer between objects with contact, and this would decrease the electric field and the force caused by the U tapes.